We're looking at multiplication theory on probability, product rule of probability. In simple words, this theorem is a way of looking at probability of things happening in sequence, each event influencing the next. So there is a particular event that has happened. How will it or how does it influence the next event? Okay, let me give an example. So here we have the example. We have a bag with red and white balls. Two balls are drawn randomly and without replacement. That's very important. What is the probability that both drawn objects are red? Okay, let me show this with an animation. So we are looking at drawing a object, right? So initially we had 3 plus 5, that is 8. So first object, if it's red, the probability of this happening is 3 by 8. Now without replacement means the same bag goes forward, right, without getting replaced. So we can see that this will remain wherever it is. With replacement also we have seen before in 11th grade. Here also we'll see that again. But I want you guys to understand this. Without replacement means it's literally without replacement. And now what is the probability of red object being drawn? It is 2 by 7, not 3 by 8. Right? That's how it is influenced. What if we had something else? Instead of red, it's white. So you can see that things will change. It will influence. Whatever happened in the first draw, right? Here is 5 by 8. In the second draw, we can see that the output does get affected. Our initial answer was 2 by 7, but here it is 5 by 3 by 7. There it was 2 by 7 in the first video. Here it is 3 by 7. So we can see that there is some influence. So to mathematically define this or find this and all of that, we use product rule of probability. So the definition is such. Probability of two events occurring together is equal to the product of the probability of the first event occurring and the product of the second event occurring given the first event has already occurred. So mathematically, if you guys look at it, you will understand the formula. See, right? We're looking at A and E happening, right? That is equal to probability of E into probability of F given E. The other way around is also true. So where have you seen this? Yes, under your conditional probability. If you rearrange this, you'll get back that. A small note, probability of B intersect A can also be written as probability of B and A in this manner. Okay, so intersect can be written in this manner as well in probability. So that's something that you guys have to know. Okay, a small note. See, conditional probability has to do with, this is your product rule of probability. When you talk about conditional probability, a particular thing has happened within that space. What is the probability that another thing will happen? Our favorable event has happened. Not will happen, has happened. This is future. This is within the same space. Okay, this is the past. This is something like the future. Right? Within the space, what is that? How is that this will occur? What is the chances of this occurring? This is like the future. Again, the funda has to be understood. Please don't go with the past, future and all of that. You need to understand the sequence. Here there is a sequence. Here it is within the same space. You need to understand that actually. The future and the past word is only to give you guys a tone of things, I guess. So please don't take it literally. Please understand this difference. If you don't understand this difference, there's no point in learning or going forward. Because application would be mix of things. They won't make it very clear what should you use where. So be clear with the product rule of probability and conditional probability. And now you have to copy.